In this lesson video, we're going to be discussing angle relationships, specifically with parallel lines. So I want you to remember what we define as parallel lines. Parallel lines are lines that never touch because they're the same distance apart at every point. So in our diagram here, let me select the right pen. These lines are parallel lines. We have any situation here, though, where we have two lines that are intersected by another line at two different points, creates this concept of what we call a transversal. A transversal is a line that crosses a set of two lines, and it can actually help us determine if those lines are parallel based on the angle relationships that it creates. And so before we get into certain angle relationships, I want to discuss with you two key terms moving forward with this lesson. And the first is interior angles. Interior angles are angles that lie within the two parallel lines. This would be like angles 3, 4, 5, and 6. They lie between or inside the two parallel lines. Now I want you to remember these are angles. Angle 3 is this angle. Okay, angle 4 is this angle. Angles are formed by two intersecting lines, rays, or segments. And so those are our numbered angles. And as we talk about interior angles, that brings up the idea of exterior angles. Exterior angles are angles that lie outside the two parallel lines. So this would be like angles 1 and 2 and 7 and 8. They are outside of those two parallel lines. Okay? And so as we move forward and talk about angle relationships created by a transversal and two parallel lines, we have some new terminology to discuss. And so what we want to do as we move through this is actually write some things out, but I'm going to be highlighting certain angles as we talk about these. So the first angle pair we look at are alternate interior angles. Okay, the word alternate means opposite sides of the transversal. Interior means they are between the two parallel lines. So between the parallel lines and on opposite sides of the transversal gives us angle pairs like 3 and 6. Okay, angle 3 and angle 6. But we have another pair of alternate interior angles, and those would be angles 4 and 5. Okay? So here's what you need to understand when we have parallel lines and these kinds of angle pairs. Alternate interior angles are between or inside the parallel lines, but they lie on opposite sides of this transversal. One's on the left, one's on the right. They are congruent, which means they are equal to each other. Okay? And so we can use that in solving equations by setting angles equal to each other. Now, since we have alternate interior angles, we also have alternate exterior angles. So outside the parallel lines, opposite sides of the transversal. So like angle 1 and angle 8 are alternate exterior angles. And then also angle 2 and angle 7 are alternate exterior angles. All right? And again, because they are outside the parallel lines and on opposite sides of the transversals, they are also congruent. They're equal to each other. So let's continue on to some other angle pairs created by parallel lines and a transversal. Okay? The next angle pair we're going to look at are consecutive interior angles. Consecutive means in order or in a row or on the same side as. So same side of the transversal, and they are interior angles. All right? So we might have an angle pair like angle 3 and angle 5 are considered consecutive interior angles. Okay. But angles 4 and 6 are also consecutive interior angles. And so here's what we know about them from this far right-hand box. Consecutive interior angles are between or inside the parallel lines and on the same side of the transversal. They're either both on the left or both on the right. And they will be in the same category as linear pairs in that they are supplementary, which means they equal 180 when added together. Okay? And then we move on to the idea of corresponding angles. Now you'll notice there are many more pairs of corresponding angles. Okay? Corresponding angles are in the same location but on opposite parallel lines, or on opposite line according to the parallel lines. So angle 1 would be corresponding to angle 5. They're on the same side of the transversal, but they're on different of the two parallel lines. So angle 1 and angle 5. Also, angle 2 and angle 6. Angle 3 and angle 7 would be a pair of corresponding angles. And angle 4 and angle 8 would be a pair of corresponding angles. Corresponding angles are always congruent. They are equal to each other in measurement. And you can kind of look at that, okay? I'm actually going to do a little visual trick with my pen here. If I trace angle 2 here, that angle, and then I actually kind of circle that, and I'm going to move that entire thing down the line. And in fact, it worked for angles 1, because I grouped that one in there too. Angle 1 and angle 5 match up to the exact same angle measure, just like angle 2 and angle 6 match up to the same one. So you can see that corresponding angles are always going to be equal to each other. All right? And then we have one other pair of angles that we did talk about last time, but it also applies to this lesson. Linear pairs. Okay, remember linear pairs would be like angles 1 and 2, where they share a vertex and they share a side, and they're lined up along a straight angle or one line. So that's one example of linear pairs. But there would be linear pairs all throughout this diagram. So one example might be, like I said, angle 1 and angle 2, or they might even be like angle 6 and angle 8. That's also a linear pair. Now there's a lot of linear pairs I could choose. I just chose to do two of them, two pairs. Remember that linear pairs are located beside each other. They are adjacent, but they form a straight line with their non-adjacent sides. The sides that are not the same as each other form a straight line. They are always equal to 180 degrees when added together because they are supplementary. Okay? And I also want you to remember, last lesson we talked about vertical angles also. Vertical angles, I'm going to erase some work here. Vertical angles would be like angles 5 and 8 because they are formed by these intersecting lines and they're opposite from each other. They're in opposite corners. So those would be vertical angles, and they are congruent to each other. Not supplementary, they're congruent. So we're going to use all these topics to do some problem solving today. And so when we look at our picture, the process I want you to go through solving these problems is to always identify the property, or maybe instead of property, think of it as the angle pair relationship. Okay? And so we're going to identify that before I even set up an equation, because the angle pair relationship will tell me what equation to set up. So the first thing I want you to do is look at these two angle measures for number 1 and realize they are on opposite sides of the transversal. That's your transversal. It crosses the two parallel lines. So the word alternate has to show up in my property or my angle pair relationship. And they are interior angles. Okay? They're in between the two parallel lines. So they're alternate interior, and I'm just going to do angle apostrophe S for the word angles. And I want you to see back up here, actually on the previous page, that alternate interior angles are equal to each other. So that's what I want to write. Actually, I want to write alternate interior angles are congruent, and we need to know that means they're equal to each other. So that's what we're going to finish out with our property. Alternate interior angles are congruent. And remember, that symbol means congruent, which means equal in measure. Alternate interior angles are congruent. You can actually abbreviate that property as alt int angles congruent. Alternate interior angles are congruent. And that's actually how we're going to set up our equation now. Because they're congruent, that means they're equal to each other. Angle equals angle. And so that's how I set this up. 120 equals x plus 128. And all we have to do here now is solve for x. So we're going to subtract 128 from both sides, giving me a negative 8 equals x. So if x is negative 8, that might seem strange, but remember, it's the value of a variable. And if I plug that in here, negative 8 plus 128 goes back to equaling 120. So that is my answer, but you need to do this part every time. I want you to write the relationship, the angle pair relationship, so that you can understand how to better write an equation. Number 2, as you look at this, these two angles are right next to each other. They share a side and a vertex, and they're both along one line, meaning they form a linear pair. So linear, I'll abbreviate, pair angles are, think about that from what we saw in the previous set of notes, supplementary. Supplementary meaning they add up to 180 degrees. So that's how I'm going to write my equation. Since they're supplementary, I'm not going to say angle equals angle. I'm going to say angle plus angle equals 180 degrees. So 10x plus 15 plus 5x plus 15 equals 180. And then I start to solve. I noticed something in the previous lesson when I was helping some of you that we have a hard time with equations like this. And I want you to understand something. We're not going to cancel the 15 and the 15. We're not going to cancel the 5x and 10x. So we're not going to do the opposite of any of these. We're not going to subtract all on one side here. We are going to combine like terms. 10x plus 5x is 15x. Okay, and 15 plus 15 is plus 30. Okay? And so then we can go ahead and subtract our 30 from both sides. Now I want to cancel when I move it across the equal sign, giving me 15x equals 150. And now I can divide by the 15 here. So x equals 10. And that's all I had to do was find the value of x. Now, in this case, we could plug in and find that angle measure for each one. 10 times 10 is 100, plus 15 is 115. And 5 times 10 is 50, plus 15 is 65. So when I add these two angle measures together, I do get 180 degrees. And that's a way you can check your work as you're going. Only when there are supplementary angles should they add up to 180 degrees. And moving along, we're going to look at a couple other examples. But the idea remains the same. We look at our angle pair relationship first. By identifying that, you should know what equation to set up. So as we look at these two angles, they are on opposite sides of this transversal, and you know the transversal is the line that connects one parallel line to the other parallel line. And since they are on opposite sides, we know we have the word alternate, alt for short, and they are outside of the two parallel lines, not in the interior, in the exterior. So these are alternate exterior angles, and the relationship of alternate exterior angles is that they are congruent, which means that the angle equals the other angle. And so we can set them equal. So we can say 11x plus 9 equals 13x minus 7, and we can start to solve. What I would do first is subtract the 11x from both sides, and then I would add the 7 to both sides in the same step. Now, you don't have to do those in the same step. You can do it this way. By doing subtract 11x first, you get 9 equals 2x minus 7, and then you can add 7 to both sides. 9 plus 7 is 16. Now we can divide by 2, and we get x equals 8. Now, if you were asked to find a certain angle measure, we would plug into whichever angle we would need to use. In this case, let's say we wanted to find this angle measure. So I would take my 13x, and instead of times x, I would make it times 8, and then minus 7. 13 times 8 is 104. 104 minus 7 is 97 degrees. Okay? So what I want you to do, and we've done several examples like these so far, I want you to try and do numbers 4, 5, and 6 on your own. This is a time when you're going to need to pause the video and try and do these things first. The first thing to do is to identify the angle relationship. Then the second thing to do is to write your equation and solve that equation. And then you can check your equation, The third thing to do is to check your equation to make sure it makes sense in both parts. Okay, so again, 4, 5, and 6 on your own. If you need more time, keep the video paused. Otherwise, these are the answers you should get. For number 4, those are vertical angles. They are across or opposite from each other along two intersecting lines. And vertical angles are congruent, so I set the two angles equal to each other. And so, when I solve that equation, I get x equals 11. For number 5, those are consecutive interior angles. My abbreviation down here in property stands for consecutive interior angles are supplementary, meaning they add up to equal 180, which is where I get my equation. When I solve that equation, I get x equals 6. And number 6, those are corresponding angles. Corresponding angles, remember, are on the same side of the transversal, and they are on opposite of the parallel lines. And they are congruent, so I set those equal to each other, and I get x equals negative 3. All right, and so what we're going to do now is, again, work through an example or two where I don't give you the picture, but I give you the angle relationship. All right? All you have to do is set up your equation. Angles 1 and 2 are alternate interior angles, which are congruent to each other. Remember, alternate interior are congruent. There's only a couple angle pairs that are supplementing. Those are linear pairs and consecutive interior angles. So all other angle pairs in this lesson are congruent. That means angle equals angle, and so I can set up that equation. 2x minus 4 equals x plus 42, but they want me to find the measure of angle 1. So from this equation, I'll solve and find x minus x from both sides. 2x minus x is x. And then add 4 to both sides here. And I get x is 46. But from there, they want me to find the measure of angle 1. So I'm going to plug back in for the measure of angle 1. Measure of angle 1 equals 2 times 46 minus 4. 2 times 46 is 92, and when I subtract 4 from 92, I get 88 degrees. And it really doesn't matter which angle you plug into because you've said they were supposed to be congruent or the same as each other. Well, number 8, we are told that angle 1 and angle 2 are consecutive interior angles of parallel lines, and they give you 2 expressions for angle measures. But consecutive interior angles are supplementary, meaning they add up to 180. So I'm going to take one angle expression, 3x minus 4, plus the other angle expression, x plus 42, to equal 180 total. So now I want to combine these like terms, not cancel them. 3x plus x is 4x. And combine these like terms, negative 4 plus 42, which would be plus 38. Then I can subtract 38 from both sides. 180 minus 138 is 142. And then we can divide by 4. When I do 142 divided by 4, I get 35.5. But they, again, want the measure of angle 1. And so I'm going to plug in for the measure of angle 1, which means I take 3 times 35.5 and then subtract 4. Three times 35.5 is 106.5, and then when I subtract 4, that is 102.5 degrees. Now that seems a little strange to have decimal values, but this does work, and you know that it's going to work if you take a look at plugging into the other angle measure. If I just do x plus 42, that's 35.5 plus 42. That's 77.5. Now, 77.5 plus 102.5 does equal 180. And that is the total for both angles. So again, this is my answer, 102.5. Sometimes we get those decimal values. Okay, that finishes our lesson for 1B.2. Your assignment will be very similar to this. You do have a quiz coming up over these 2 lessons, and the quiz questions will work very similarly to these, where you have to identify the property and angle relationship, then put in an equation and solve your equation to answer the question. But pay attention on the assignment. When it says to find the angle in bold, you should be able to tell on that picture that one of the printed angle expressions is usually a little darker than the other, and that's where you're plugging into. Okay, so if you have any questions, please send me a message in Canvas. Otherwise, you should be good to get started.